So we've just had quiz 2. I'm not sure exactly when we'll have quiz 3, but we're going to continue to use computers most days, and so it would really be to your benefit to have the computers both for the in-class exercise and potentially for the next quiz that we have. There may be a handful of days in the foreseeable future where we won't use your computer, but most of the time we will. The graders started working on homework 4. The next one, homework 5, that's due on Tuesday of next week, and the submission is closed at 8 a.m. on that day. Any questions on the announcements? All right. The notes that you may have in front of you, if you've printed out the notes, are a little bit different from what I'm going to show on the board. I thought that they were unnecessarily busy and confusing. There was just too much going on in those slides, and I thought I could improve. And so you may need to just take notes by hand or rewatch the video later if you want to have access to this stuff later on. But what I want to show you is if we have a complex cash flow diagram like this, where there are several different things happening, how to create an outline or kind of like a solution strategy before you actually start doing the calculations. You may remember, if you've ever taken a programming class, that sometimes what we'll do is generate pseudocode before we go to the trouble of actually writing the full-blown code where every space has to be in exactly the right spot. Sometimes beginning with an outline and maybe even doing like a graphical representation of that outline can be useful later on. Okay, so let's just go through what steps would be required to take this cash flow diagram, all of it, to the present. And right now there's no amount already at the present. And so if we look at what's happening, it seems like in years 9 through 11 we're going to receive an inflow of $1,100, and then years 4 through 7 there's both an annual series and a gradient that's happening. Now the thing that's going to be tricky is that the 0 year of both of these, in terms of our standard notation or the convention that we use to solve problems like this, the 0 year is going to be relative. It's not going to be our absolute 0 year. So what I mean by that is, on the quiz that we just did, you saw that when you have an annual series and you're taking it to the present, P, which is meaning the present, is the year before the annual series begins. And so it's 1 year back from the first time you see the annual series. That's what we call year 0 with air quotes. So here for the 1100, where is year 0 relative to that annual series? 8, right. So if we take it to a single present value, if we do find P given A on this 1100, we're going to be taking the amounts to a single amount in year 8. And then we'll have to bump it from 8 to 0 to get it to the real present. So the idea that I'm introducing here is the difference between a pseudo or relative year 0 and actual year 0. The pseudo year 0 is just where we temporarily take amounts because of the convention for converting between an annual series and a single present value. And so the same thing is true down here for this annual series and its gradient. The gradients is what gives people particular trouble. What is the value of G in this gradient on the outflows? G equals 100, exactly right. Now, what's the pattern of a gradient? Remember, the first time you actually see that 100, which year is that in relative to the gradient series? Right, year 2, because it goes, the pattern is, first there's year 0, then in year 1 of a gradient, it's 0G. So you're not actually seeing any added amount. Then in year 2 is when you see 1G. So here is 1G, the year that we have 600, so that's, relatively speaking, year 2, which makes this, where there was the 500, year 1. So the pseudo year 0 is here in year 3, both for the annual series and also for the gradient. It could have been that there was 500, 500, and then 6, 7, 8. If it was 5, 5, 6, 7, 8, then the year 0 for the annual series would be different than the year 0 of the gradient. So that's a possibility as well. All right, so let's step through these, the strategy. And so what I'm going to ask you to do is when you have a complex cash flow diagram like this that you are solving by hand, for instance, on the in-class exercise I'm going to give you, write on your paper step 1 and find a way to express what you're going to do. Don't just jump straight into looking up the factors, because more often than not you'll introduce error compared to if you take the time to outline your strategy. That will really be a good investment to avoiding error, and it's easier to follow what you've done as well. All right, so what are the steps? First of all, step 1, take 1100 from where it is right now to year 8. And then here in my little outline, I've even said what factor I'm going to look up. So P/A means find the present given the annual. I actually isn't defined for this, so we'd have to find the table for whatever the I is, and N equals 3. Now I'm calling this step 1. We could have started with the outflows, and you'd eventually get the same right answer. So it's not required that you first do the inflows, then do the outflows. You can have different paths to the same eventual right answer. And I want to emphasize that here, step 1 doesn't have to be this annual series on top. Okay, so by take, what I mean is think of it graphically, visually. Where is the money moving? Right now it's in 9 through 11. What we're going to do is we're going to transfer it all to year 8. So there's going to be some amount in year 8 that we've converted the 1100 from. I want you guys to fully appreciate this animation that I've just showed you. It took me a long time last night. It was a big investment. I stayed late so that I could show you this. Wait for it. Oh man, that's sweet, right? All right. So that really illustrates the point of what we've done. We had this, we turned it into that, and so that's not there anymore. Okay. So that's the result of step 1. Any questions so far? Well, some of you are probably thinking, well, I wonder what step 2 is. You can't wait. And you're thinking, well, this needs to go to year 0. You're thinking right. Step 2 is move the amount that we've just created in year 8 and move it to year 0. Sometimes a point of confusion for students is that in step 1 we called it P, but it wasn't really our real present. It's in year 8, right? Our real present is in year 0. But we're just briefly, temporarily calling it present because we needed to convert it to a single amount. So in step 2, this amount at year 8, we're no longer thinking of it as present. Now, from this point of reference, we're saying this is actually a future amount. This is where we're acknowledging the fact that it's in year 8, and that's not our true present. Our true present is 0. So now we need to move it to year 8, so we're going to do P/F, where F is however much we had found in the previous step. So in terms of like a visual representation of that, we're going to take that big single amount in year 8 and move it to year 0. To year 0. All right? And then it's not there anymore in year 8 once we do that conversion. All right. Any questions about this? All right, you can see where this is heading, right? We've got these amounts down here. They need to be moved around. So step 3, it's a toss-up. We could have done the gradient first, or we could do the annual series first. I'm saying, well, let's just do the annual series first. So we've got this A equals 500, and we've got 4 of them. And if we do P/A, that's going to move it to year 3. So there it is. And so it was these amounts that really aren't there anymore after you do the conversion. And then step 4, we have to deal with the gradient amounts. So we'll convert that, the 100, 200, 300, converting those to year 3. And so now we have a big single amount in year 3. And our final step is to move it from year 3 over to year 0 with P/F. So in step 3 and 4, we were finding what we called a P, a present value. That just meant the year immediately before those series. But what we really know is it's in year 3, and 3 isn't the present. 0 is the present. So now here in step 5, we're saying, well, these amounts in year 3, we're going to move it to 0. And then it won't be in 3 anymore. And our final task is to combine all of the amounts at the present to find out what's this net value, whether it's a positive or a negative. We don't know until we actually do the calculations. So that's an illustration of a strategy. It doesn't have to be the same to get the right answer, but it's really beneficial for you to take the time to outline your solution before you calculate it. All right, so here's our in-class exercise for today. I've just kind of transposed that cash flow diagram. I'd like you to find on paper, using the factors that I've provided, what's the present value of this. And before you jump into the numbers and start looking up the factors and whatnot, I'd like you to take the time to outline your strategy. All right, now, of course, you're more than welcome to collaborate with your classmates. In fact, I encourage it. Talk over amongst yourselves how to solve this one. I'm going to pause the recording, give you some time to start working on it, and then we'll look at the solution together. I'm not a very good mind reader. In fact, I'm a really lousy mind reader. And the reason why I mention it is as I was walking around, I noticed that many of you didn't take the time to write like what the steps were. You didn't label them step 1, step 2. Some of you didn't write like a little brief commentary of what you were trying to do. If all you do is just write down the factors and you happen to get it wrong, I'm not going to be able to give you very much partial credit. Because I'm not going to know what you were trying to accomplish if you got it wrong. But if you write step 1, I'm taking the repeating 11,000 from 2 through 4 into one amount at year 1. Like if you kind of give me an outline of what your thought process was, I'll give you a lot of partial credit if you had the right idea but you looked at the wrong row. So if you just happen to look at the wrong row but like you understood the mechanics of how a problem like this is solved, I mean, you'll get the vast majority of the points. But my suggestion is it's really important to give me something to work with. Let me know what was your thought process. Find an effective way to communicate what your solution strategy was, because If you make a mistake, and it's easy to, there's lots of different things going on here. There's calculations, there's lookup, there's analysis. So there's a lot going on, and it's easy to make the mistake. So that's just another emphasis I'll give you to the fact that you really need to find some sort of a detailed way to communicate what you're trying to accomplish. So what I did was I turned the annual series inflow to an amount at A, and then I moved that amount at A to an amount at B. So you see in step 1 I was creating that single amount in A, and so I label it both on the sketch and then over here I've got this amount, and that's what this arrow A is. So it's 28,348, and then I moved it from where it was in year 1 to year 0, and so it's a little bit less when you discount it. And we also, in addition to just calculating these amounts, do a reality check as well. Is it reasonable? Does what we're seeing in the numbers reflect what we know in theory? And what we know in theory is when you move amounts backwards in time, they get smaller. They're discounted when you're moving money backwards in time. And when you move money forwards in time, that's compounding. The amounts gets larger. So the fact that this 26,247 is smaller in year 0 than the equivalent amount in year 1 was 28,348. So that makes sense. We can do that reasonableness check on the fly. So we now know the present value of the inflow. We can turn our attention to the present value of the outflow. So there's a gradient and an annual series. So in step 3, what I'm doing is I'm moving the annual series to year 6. And step 4, you'll notice here, just because I don't want to lose track of when is the actual year 0, so I made this secondary time axis on top here. As I said, here was when we had 0G, then 1G, 2G, 3G, just to help drive home the point and emphasize that this amount D, which is the equivalent value of the gradient once it's been moved to a present value in air quotes, because it's not really a present value, it's just 2 years before the first time we saw any effect of the gradient. So that's the quasi year 0 in the actual year 6. Yeah?
When we were doing the first stuff
Mm-hmm.
on step 4, you had it as the G 100 from 4 to 7.
So now, are you asking about the in-class exercise?
Yes, but you have the variable n equals 3 on the first one, and then you have it as 4 on there. Is there a different reason? We have the same amount of steps in years, but
I may have a mistake then. Let me have a look at that. No, I don't think I do. Oh wait, here's the in-class exercise. Let me go back in the slides. No? Yeah, it was 4. Okay, so back to the in-class exercise. So the steps that we do is we move the gradient to year 6, the annual series to year 6, and then those combined amounts have to go from 6 to 0. So in the end, the value that you should get is 12,880 when you combine the inflows and the outflows together. All right. Are there any other questions about the in-class exercise, or not only the underlying assumptions of like what's the quasi year 0, or how do you look up the factor out of the table, but also, you don't have to follow the same notation method as me, but you should develop something that works for you, whether it's labeling the arrows that you create, or whether instead of calling it step 1, you call it first step or whatever. You just have some sort of a system that you're able to communicate to somebody what you were thinking. And one of the risks is if you're just writing down the factors, you don't know when the money is. You know what the amount is, but when is almost as important as how much. Those two are equally important, because if you lose track of the when, then the amount is irrelevant, because you may take it to the wrong time. So when is every bit as important as how much, and so that's why I'm always saying when I'm taking it from and where it's going to. So from, to. All right. I won't further belabor the point. Let's move on in the in-class exercise to the second problem. This is one where you're going to need Microsoft Excel. And in class last time, we went through a spreadsheet example of how to calculate a future amount. Do you remember what were the column headings that we had when we were calculating a future value in Excel? So we had interest up at the top, and then what were the columns below that interest rate? Year. And what was the next time column after that? Right. Well, it was a secondary time column, years until, and then whatever year you're moving the money to is what you'd put in that. So in this cash flow diagram we're looking at for this next in-class exercise, all right, so it says we need to move it all to year 16. So in this case it'll be years until year 16. Because remember, our end value won't just be what year it's already in. Our end value will be how many years is it until year 16. So our column headers are going to be year, years until year 16, amount, and then future value of amount. And remember, there's that function equals FV that you can use. But what's the two tricks that we need to apply when we're using built-in functions like PV and FV? There were two little warnings I gave you to be on the lookout for. What are they? Anybody remember what those two commonly made mistakes are when applying the future value or the present value function? Okay, yeah, the first one had to do with applying a negative value inside the function, because by convention, what Excel assumes is that one of them was an inflow and one of them was an outflow. That's what Excel assumes. Well, in our case, we don't want it to change the sign. We just want to change the timing of the amounts. So in the function, you're going to have to apply a negative value when you put in the present value. So the FV function, one of the things it's going to ask you to tell it is what is the present value. And you'll put in a minus sign before you click on the cell that contains that amount. So there's the negative sign. What was the other warning? Very good. Skip the field that says PMT. What does PMT stand for? It stands for payment. And the reason why we're skipping it is that if you put an amount in that field, it's going to assume that there is n of those that you want to convert to whatever your date is. And what our approach strategy here is that it's just all a bunch of single amounts we're converting into the future, row by row. So skip the payment field. All right. So I'm going to stop talking, giving you a chance to find the value of this cash flow diagram in year 16. And then once you get that solved, once you do part A, you can attempt part B and C. I give you a little hint on how to do it on the paper, but I'll demonstrate in case it doesn't make sense to you. We'll go through it together. Okay, if you've forgotten how to do the FV function, I'm going to do it here on the screen now if you want to just watch. I won't talk through it to interrupt the rest of the people, but here I'm going to do the FV function. All right, so let me just re-emphasize our basic approach here. So we've got a column for time, and then a column reversing the time. And this isn't strictly necessary. You could have put an equation inside the function that calculates the correct n that you need. But that's just another opportunity for error when you're trying to embed too many things into a single function. So I always suggest just create another column that shows the n you're actually going to put in for each row. So why is this 16? It's because this amount, this 3,500, how many years do we have to move it to get to the end of the cash flow diagram? Well, we need to move it 16 years. So when we do the function, we're going to need that function to look at the number 16. So here it is. That years until 16 is going to be the number that it looks at for that row. Then all of the amounts, it's easy to lose track of which one is a negative and which one's a positive. So be sure that you maybe double check if it's below the cash flow diagram that you've got a negative value for each of those amounts. And for the future value function, what we're doing is we're saying equals FV, and then we click on the rate along with the dollar signs. So you can either type those in manually or just press the F4 button to anchor both the column and the row. N is going to be this secondary time. And then in this case, we want to skip over the payment field, so we put in 2 commas and then negative of the amount. The negative because if we didn't, it would switch the sign, and we don't want it to do that. All right. And so we can drag that formula down and then total all of them. And the reason why we total them is each one of these rows is telling us the future value of some amount that's been compounded into the future. So 3,500 moved 16 years. Just that one amount is 9,233. And then these two 9,000s, even though they're the same amount in their respective years, they're different amounts if you compound it into the future. The reason why this one is worth more in the future than that one is it was compounded for more years, and so it continued to earn interest an additional year. And so that's why it's larger. So we add it all up. All right, so part A asked the question on A, what's the value of the following cash flow diagram in year 16? So we solved that. What I'm going to do is I'm going to create a whole copy of this. So down at the bottom where you have the tabs, I'm going to name this one 2-A. And then if you right-click on it, move or copy, we're going to create a copy. And so now we've got this other one that I'm going to call 2-B. And the reason why I did that is I'm going to be playing around with the interest rate on the second part of this question. I don't want to lose my answer that I had in part A. So by creating a copy, I can monkey around with part B, and part A is still there, fresh and pure. I know my answer, you know, and you should follow a similar approach to this on your homework, that if I ask you to change something in a second part of a question, create a copy so that the first part is preserved. All right, so B. The question says, after solving A, determine what interest rate would make the future value 100,000. So play around with the I value. So right now, if we're earning 6.25% interest, the sum of the future values is 61,157. So it's going to take more interest to increase the amount. So here what we're doing is our goal, future value equal to $100,000 by changing the I value. Oh, it always changes it. I value shown above. So then I just write a little note to myself here. Changed this until sum of FV equals 100,000. You know, just kind of outlining what was the thought process here. So is it 7%? 0.07. No. Is it 7.1%? No. 7.2%? No. 7.3%? Well, that's tedious. We'll do data, what if analysis, goal seek. And our goal is we want this cell to be a value of 100,000. And we're going to accomplish that by continually changing the amount that's in the interest rate cell. Okay, so our goal is the sum should be 100,000 by changing the interest rate. So I click OK. It's going to think about it for a second, try a bunch of different values, and ultimately it turns out the answer is 17 point. Oh no, wait, hold on a minute. What happened? Oh, I must have canceled it. Data, what if analysis, goal seek. All right, set the sum equal to 100,000 by changing the interest rate. Okay. All right, 17.24. Yeah. So now our sum is 100,000. So this allows you to do a hypothetical. Like if you want to retire with a certain amount of money in your bank account, you'd say, I want $1 million when I retire. What interest rate is it going to take to get $1 million? You could do a cash flow diagram that represents all of your savings throughout your career, and then keep playing around with your interest rate until you find the sum total, whatever it is. You know, that just is an illustration that with Excel, it allows us to solve for some unknown interest rate really easily. Any questions about part B? All right. Now, it's more, in this class, it's more than just being able to plug numbers into equations. You have to demonstrate that you understand. So on part C of the question, I ask you to explain. In the space below the diagram, describe why must the interest rate increase in order for the future value to increase. So why was it that we had to have a higher interest rate instead of a lower interest rate? So you'd say something along the lines of moving money into the future is compounding, and the higher the interest rate, the more interest you have. We were originally only at 61,000, so to get it higher, we need more interest, and so a higher interest rate. So just talking through the directionality of the solution. Okay, so you all have question 3 as well. This is kind of just to remind you of the rate function in Excel. Let's say we had this cash flow diagram. So create a new tab where you calculate what is the interest rate associated with this cash flow to the nearest 100th of a percent. All right, so let's copy this cash flow diagram over to Excel. You can't do that. I can. All right. So the rate function, we can actually just key the values in or click on there, equals rate. Okay, the first thing it wants to know is the number of years. So it's 7. And in this case, we're not going to skip over the payment field because we do have a recurring payment where there are 7 of these 7,500 dirham inflows. And the present value, remember, we have to key in the negative sign there, minus 44,560. And then we don't necessarily have to type in these things that are in brackets. So there's no single future value in this cash flow diagram. The type is asking if the payments are at the beginning or the end of the year. In our case, they're at the end of the year, which is the default assumption Excel also makes. And if we wanted, we could put in a guess. It would help Excel to calculate it a little bit faster. Let's do that just for laughs. We'll skip over the future value. We'll skip over the type, but we'll put in a guess. Is it 1% maybe? And with that guess, it'll calculate it 1/1,000,000th of a second faster. 4%, now we need to know it to the nearest 100th of a percent. So now I have to go in here to display the decimals. And it's under the Home tab, Increase Decimal. So to the nearest 100th, it's 3.73%. Any questions about that? All right, then, that's all for today. Let me remind you that the next homework assignment's due on Tuesday. I won't see you between now and then unless you come to my office, and I'd welcome you anytime you've got questions or need help. Feel free to stop by my office. If you send me an email, I'll do my best to respond, and sometimes it's me and my phone out in the middle of the woods, and so if you ask a question about your homework, taking a picture of that may give me an opportunity to respond sooner than I would if I have to wait till I get back to the office and get my textbook and that sort of thing. So however I can help, let me know. Have a good weekend, and I'll see you on Tuesday.